Yes, your questions. Questions? You were so eager to ask questions in the break. Nobody? Okay, so I have questions. Okay, this was one of the questions. We have a parallel plate capacitor. It has equal and opposite charges. They are separated by a distance d, and then we just increase the distance. So what happens to the potential and the charge? And most of you have said C, which is the potential increases, whereas the charge is the same. Well, this is the correct answer. Since the charge is the same, the electric field is constant, independent of the separation. If you are increasing the separation, you are increasing the potential of the system. Now, let's continue to another question. It is almost the same question. The only difference is now it is connected to a battery. Before there was no battery, now there is a battery. So what happens? You can just send an SMS to 4660, free of charge. Now, once you send your answers, you can just discuss. And even before sending your answer, you can discuss with your friends. Okay, there are only 40 answers yet. I'm expecting more. I mean, almost all of you got it right. Q doesn't change, V increases. You cannot change your answer. It's just once. Okay, so let's discuss why, which one. So these are your answers. Okay, so you can see why A. There are about 8 students who said it was A. Now, first let's discuss why V. Does V increase, it is the same, or it decrease? Nobody says it decreases, so why should it be the same, or should it increase? Okay. Okay, so since it's connected to the battery fixes the potential. So does anybody still think that it is V is the increases? Or do you all agree that now V is the same? Now, so Q. So we all think that V is the same now. What happens to Q? So does everybody agree with that? Okay, so the answer you are saying that is V is the same. V is the same. Q increases. No, Q decreases. V is the same. So none of the above. Does everybody agree with it? So all these people, do you agree with that? Or you just want to stay silent? Okay. No, V is the same and Q decreases. So none of the above. Okay, still we have more or less a similar system. We have a parallel plate capacitor. It doesn't have a battery, and the separation is increasing. Now this time, what about the energy stored in the capacitor? Does it increase, decrease, or stay the same? So are you sure that your neighbor also has the same answer? The exam includes everything that we have done until today, until the end of this hour. And if we happen to have some additional lectures before the exam, it will also include that one. So shall I stop? Okay. Why A? Why do you think that the final energy stored is smaller? Okay. How are they related, the capacitance and the stored energy? Okay. So if you are saying that if capacitance decreases, then the energy decreases. Any objections, any support for your friend? Stored energy does not change. Okay. So what is wrong in his argument, do you think? So you are saying Q changes, C changes, so you cannot really just look at C. Since energy is conserved, so energy should remain the same. So your friend is saying that since we are doing positive work, so we have opposite charges, so they are trying to attract each other, but we are pushing them apart. So we are doing positive work on the system, and the work that we do is converted into the energy stored in the capacitor. Yeah. Okay. Take your time. Any objections or support? So now we have, do you have any objections to him? You agree with him? Okay. Okay. The charge or the capacitance doesn't change. Okay. Okay, so you are repeating his argument. He has a second argument now. He says that the energy stored in a capacitor is Q squared divided by 2C. Since this is an isolated capacitor, Q doesn't change, just like the question that we had discussed, the previous questions. Q doesn't change. C is decreasing, but since the energy is Q squared over 2C, C being in the denominator, if C is decreasing, the energy is increasing. Okay, any objections to him or him or to him? Any more comments? And I would also support your friends who say that the energy is increasing. You can have these 2 points. The system is isolated. You are doing positive work, so the energy should be increasing. So it's B, or you can just take the more analytical approach. You can say that the Q is constant, C is decreasing, so the energy is increasing. Now this was the question when the capacitor is isolated. Now you can guess the next question. What changes, or does anything change? No, not this one. Okay, so let's stick with this one. What would have changed if there was a battery connected to the system? Now this is the question when there's no battery, but what if there was a battery? The capacitor is connected to the battery. Hmm? Okay, so if you use this analytical approach, you can also say that the energy stored is 1 over 2 CV squared. V is a constant since it's connected to a battery. If C is decreasing, the potential energy stored in the capacitor should also decrease. So what doesn't work in the other approach, when you were using the conservation of energy? We are still doing some positive work on the system. So why does the energy of the stored in the capacitor is decreasing? So, I mean, the answer that I would like to hear is that, okay, we are doing work and this work is stored here or there. So where is it stored? In the battery. Actually, you are doing some positive work, but the work that you have done, I mean, remember, when you are increasing the separation of the capacitor, the charge is decreasing. So the charge is going back to the battery. So you are also doing work on the battery, not on the capacitor. You are doing work on, the work that you do on the capacitor is transferred to the battery. You and the capacitor are doing positive work on the battery. So still we have energy conservation, but in this case, since you are doing work against the battery, the energy stored in the capacitor is decreasing. Well, this will be charging the capacitor, and if you try to charge not a rechargeable, unrechargeable battery, you wouldn't like to do that. But if it's a rechargeable battery, the charge in the battery will be increasing. Those smartphones are an example of where you use the capacitors. That is mainly how they determine where you are touching on the screen. Well, there are various touch screens. The capacitive touch screens is measuring the change in the capacitance. So, for example, if you touch it with an insulator, it has no effect. But take a conductor like a spoon, and you can use your touch screen. I think it was in Japan or China, in winter, what people used to use their touch screens was a sausage. It's a conductor, it looks like a finger, so it works. It's affected by the fact that you are a conductor. You are a conductor, you are changing its capacitance. Yes. I mean, when you put your gloves, the change in the capacitance due to your finger is reduced. So you increase the sensitivity, but then you are also increasing the noise. For example, this screen where I'm writing, it has another means of detecting the touch. This has both the capacitive screen, I can use it with the touch, I disable it, but I can also use it with a pen, which is not a conductor. For example, the styluses, if you buy a stylus for your touch screen, they're a conducting rubber on the tip. No, they're not, not this one, but for the ordinary smartphones. I mean, they are not, they are not sensitive to the pressure. But you have that large conductor in the rubber tip. And that's why they are large, so that the capacitance will change significantly. Okay, let's come back to this question. Okay, does it work? Okay, so YA, the charge stored in the capacitor increases. Okay, let's come back to this question. Not the smartphones, but the charges in the capacitor when we insert the dielectric. So why do you think that the charge stored in the capacitor increases or decreases or stays the same? Yes. Okay. Mm-hmm. Okay, your friend is saying that we are increasing the capacitance. If V is the same, so Q is nothing but the capacitance times V. V is the same, C increases, so the charge should increase. Any objections to him or? Okay, some other reply? Yes. Why? So you are saying there is no battery, so V will stay the same, the capacitance is increasing, so Q will, why? C is decreasing or increasing? Okay, so you also agree with him that Q is increasing. Okay? No, I mean, don't forget about the answer. You are supporting the answer that it is increasing. Okay. Anybody else? Okay, so you are saying that the charge will be transferred to the insulator, so it will decrease. Anybody else? So your friend is saying the charge, there's nothing that the charge, nowhere that the charge can go, so the charge has to be there. Yeah, well, I would support that it stays the same. Some of you had pointed out that, okay, some of the charge will be transferred from the plates to the capacitor, to the dielectric, but that charge is still some charge that we can get back from the capacitor. So in a sense, that charge is still stored in the charge stored in the capacitor. When we are talking about the charge in the capacitor, we usually mean that the charge that we can cause the flow by connecting the capacitor to some other circuit. So since it's not connected to a battery, so there's no reason for the potential to be the same. But since it's not connected to a battery, there's no place that the charge can flow to, so the charge will just stay the same. And as your friend pointed out, if you put the dielectric, you are mainly reducing the electric field, and hence the potential is being reduced. There's a smaller potential difference now due to the presence of the dielectric, but the charge is the same. Now this time, the same system, but it's the energy. What happens to the energy? Yes. Okay, so the energy stored, why does it increase, decrease, or stays the same? So energy decreases. Anybody who agrees, disagrees? So those around 20 people, you just agree so easily. What about from the point of view of energy conservation? Can you reach the same conclusion using energy conservation? Okay, one point of view is just using this expression that the energy stored in a capacitor is Q squared over 2C, C is increasing if you put the dielectric, so the energy stored should decrease, which is the correct answer. This is one point of view of approaching the same problem. But for example, in the other problem, we also had this approach using energy conservation. What can you reach the same conclusion using energy conservation? How? Why? So? Okay, so you are saying that we are doing a negative work because we are trying to pull, the capacitor is pulling it inside. So the capacitor is doing positive work, so it's losing its internal energy. It's using its potential energy to do positive work on the capacitor, on the dielectric, while it's pulling it inside. So its energy stored is now being decreased because it's being used pulling the dielectric in. Or as your friend pointed out, since the force that the capacitor exerts on the dielectric is to pull it inside, we have to exert a force in the opposite direction. The displacement of the dielectric is towards inside. We are exerting a force on the opposite direction, so we are doing negative work. This negative work is decreasing the internal and the stored energy in the dielectric. Any other comments, questions? Okay, then see you on Saturday at 1:30. We will be here. Well, most of you will be in this classroom. Some of it will probably be in U2, and probably none of you will be in U1.